Hello, everyone. How are you all going? Good. Now I get to tell you a developer joke. Do you want to hear one? Yes. Oh, you don't sound convincing. All right. How many developers does it take to change a light bulb? None. It's a hardware problem. There's plenty more coming. It's so awesome to be here. I come from the time zone of GMT +10, and I bring with me the gift of the metric system. It's amazing how many times that never gets accepted here. But yeah, it actually is really amazing to be here. I come from Australia, as you can probably tell from the accent. And it's super cool to be able to share some IoT stuff with you today. So let's go on a bit of a journey. IoT for me as a dev is an amazingly magical world where it allows me to take my online world and bring it into the real world and create whole new experiences for people to be able to interact with. I don't know if many of you are staying at the hotel, but in your room there's actually three IoT devices around the minibar, basically pressure plate sensors that basically enable like a seamless experience. You won't even know they're there. They're just seamlessly part of the room experience. And ultimately, what does this mean for the DevOps world? Like, what is you basically going to be dealing with? Essentially, like a bucket load of connections. Because it's everything around you, everything needs to connect in and talk to a server and build out that experience. And as a dev, I absolutely love being able to build out and sort of facilitate that whole new user experience. As a technologist, dev, and all-around geek, I love IoT. It's the endless possibility of things that enables developers, dreamers, and those that dare to be able to imagine the seamless experience that can be built into the world around us. As a dev, it does move my online world into the real world, but there's a whole bunch of challenges that come with that. Being able to interact with things around you and sort of create that seamlessness, that magic, if you will, is the cool factor, like the cool thing. Once you sort of overcome some of the connectivity and various sort of IoT over-the-air update and also device management challenges of millions of things. Probably one of my favorite sort of examples of ways that IoT can be used. This is Jibo. I don't know if anyone's familiar with it, but it basically enables like a connected thing to have a personality, which is really cool because it allows me to relate as a human, as a person, to the technology that I'm able to use and interact with. One of my all-time favorites, and I've been really watching this one for a few years, is FARMBOT. And FARMBOT enables you to basically remotely control and interact with your own garden. Best part is it looks after itself. So you can interact with it and still be able to do gardening things because that's fun for relaxing. But you can literally watch it grow remotely. So if you're traveling, like it can look after itself, it can water the plants, it can actually plant new seeds and also weed the garden. The best part is it's all open source. So there's a thriving, almost growing community, if you will, that there's a pun there. That basically makes it better. The really cool part of this is this potentially could run on other planets. Like we could send this stuff to other worlds and have things start growing before we even get there, like years ahead of time, to know how the environment will handle the stuff that we're going to need to survive in. Again, like the fact that an open source community can help build that's amazing. It literally does go to whole new worlds. And of course, we already know like the number of IoT things, particularly in industries, is massively growing. So smart cities like parking meters, trash monitoring, trees. In Melbourne, the local government there actually connected all the trees through the Melbourne CBD. So each tree had its own email address, and you could get all sorts of temperature sensors and all sorts of different sensor information from the actual trees remotely. Plus, people were sending fan mail to the actual trees, to the email addresses, just to help them grow. And yes, Statistica predicts there are 23 billion connected devices right now this year. which worked out to about 3 devices per person. And I know at home, like I've got a bunch of stuff, and that probably doesn't surprise anyone, including a 3D printer, which we're going to have a look at some stuff in a little bit. But all open source and super, super cheap. It was about 170 US, and basically enables me to sort of build out those experiences even more and into a nice little package. You're going to see some stuff that I've done with that recently. But this starts to, I love this saying. So this is sort of a meme in the IoT world. In the Internet of Things, nobody knows you're our fridge. And it's so true. As DevOps, like you're going to be dealing with things that you won't even realize are not people. Like it's going to be coming through in millions. It'll be like connected to your servers. You're not going to know what you're dealing with, whether it's a button, a fridge, a car, a TV. Like there's going to be all these new connections popping up. Probably one of the biggest things that the IoT industry is faced with sort of last few years, and we'll take a look at sort of the timeline and how that built out, was connectivity. So having a device sitting in a room or monitoring a plant or somewhere in the world doesn't really help anyone if it's not able to connect to or talk to network. Particularly if the devices can't talk to themselves, then yeah, that massive challenges with how that's been built out. And it's kind of been a little bit of the devices catching up alongside network deployments. And we'll take a look at some of how that's played out. Probably, so going back to 2013, we started to see some of the first Arduino Wi-Fi boards. Basically, something the size of that was in 2013, cost about $70. The first one was an Arduino Yun that was first released. I got one in sort of early 2014. And it was a great little board. Had some quirky behavior on the actual board itself. So there's 2 sides of the board. You'd have an Arduino side and then an OpenWRT image basically running with a JSON bridge in between. The JSON bridge was so latent. As a dev, it drove me nuts. Easily replaced though. And not only that, but 6 months later, so something that size, 6 months later, we're seeing something the size of that. And I happen to bring some with me. So basically that. So we went from $70 Arduino Yun. 6 months later, we had $6 ESP8266-1. 6 months after that, and this is the amazing thing that really blows my mind with the IoT world, is this stuff moves so fast. 6 months later, we had the 12, which is that. Both of them have Wi-Fi, and both of them are like really, really cheap. You can literally buy them in bags of 20 just online. Again, this sort of started to build out that experience. The problem was there was a bit of a conundrum, because while these were little Wi-Fi-enabled chips were basically starting to revolutionize the world around us, and there was a whole bunch of companies. I think Spark also did one, Spark Core. They were really cool, really easy to use, amazing seamless online experience. But yeah, the problem started to become like Wi-Fi doesn't reach everywhere. So for these things to work, I basically had to have a Wi-Fi-enabled network running. And plus, if I wanted to sort of consumerize some experiences, I then had to enable the users to be able to set up their Wi-Fi, and therein lies the problem. Which started to get to a bit of conundrum, like which should come first, the network or the device? Like which one takes precedent? And I guess it was in that time we started to see the rise of your closed proprietary networks. So Sigfox, LoRaWAN, which do like amazing work, and they have some really good use cases, particularly in Edge these days, where you can have, we'll talk about that in a sec. But we started to see some of the proprietary closed networks rise up just to meet the demand, because there wasn't any sort of standard protocol at the time. And that's where edge computing sort of started to come out more and more too, because you could have an extended LoRaWAN or a Sigfox sort of edge that would have sensors or a number of different devices connecting to one point that would then talk to networks. So you'd have a LTE, like a 4G, 5G, 3G connection from the actual edge that would gather all the sensor data and push it back up to your cloud. I mean, pretty easy, right? Which, particularly in the use case of farming or mining, you could have like an edge base that would collect data, and particularly in remote areas, this is still common practice, is you'll have all these devices and all these connected things talk to this one edge that then pushes up to your cloud. With some of the mining setups in that sort of use case, they'll actually pass information back between the trucks as they pass each other, because sometimes the networks can't reach a fair way underground, or even a wide area of coverage. And then 2016, 3GPP started to standardize sort of the CAT0, CAT1 LTE networks. And what that meant was, for the first time, there was all of a sudden, telcos were able to start offering very specialized IoT networks. Sort of before that, one of the last projects I worked on as a full stack dev, it was a GPS cat tracker for a pet food company in Australia. And the problem was, it was running on the 2G network, so it was extremely power hungry. It would basically try and connect and send a TCP string to the 2G network, if it could connect, every 10 minutes. And if it couldn't connect, then it just kept trying until the battery died. And that was on full-blown LTE. Whereas with CAT0, CAT1 networks, like really, really easy, really, really light, very low powered, and because it's only sending like a very, very small set of information, like a small packet string, it was a lot lighter. Sadly, my GPS cat tracker would basically only last for about 8 hours if it had connectivity. With the CAT-M1 and some of the narrowband networks, like we can have devices that run for years without needing a battery change or a recharge, just because it's so low powered and it's sending such low information with an extended and mature network. And that's the thing, as the network, and of course, everyone was egg static. There's another pun there. I've got so many more, don't worry. And so as devices as the network has basically matured, devices have gotten smaller and smaller. The one on the bottom right, it's actually just been announced by Arduino, which is super exciting. It's something the size of that, which is super tiny. That's got narrowband and also CAT-M1 in it. The difference between the two is basically how much data they're able to transmit over the network. So narrowband, not quite as full bandwidth. Essentially, CAT-M1, you can make VoLT, voice over LTE calls through, so you don't even need regular mobile network. Whereas narrowband, you could probably do it, but it's not going to like it. So the bandwidth's not quite as strong, but the coverage is like so much more wider. Like you're going to get a lot more coverage out of your narrowband network. Also, sort of height-wise as well, like narrowband will reach further underground. Recently, sort of this year, the Android things went into what I'm going to call release 1, although Android was kind of it was something they were working on for a while. One of the more exciting things with this, though, so the actual boards, it's about the size of a Raspberry Pi. In fact, you can use a Raspberry Pi 3. The boards themselves actually run Android, which use ADB to connect to. You can actually program them with Android Studio, which is really cool and interesting because it basically opened up any Android developer to IoT things. And they can build that into mobile experiences really, really easy. The exciting stuff with this, and this is where regular IoT and sort of edge computing is starting to merge a little bit, is the boards themselves can run TensorFlow mobile. So all of a sudden, you can hook up a camera and be able to do stuff before you actually need to send anything to network. The board itself can do the processing for you, as opposed to having to send everything up to your server. Again, poor DevOps having to deal with a whole bunch of images coming in every minute to be able to work something out, and then push back a response when it needs to. So monitoring, environmental resources, cars, people, like being able to do that on the actual board itself and just transmit the result saves so much time. Also bandwidth as well. However, that was just the beginning. So just getting a device on network is kind of the first piece of the puzzle. Once you actually get it on network, you need to be able to manage a whole bunch of devices. So what that means is you get like 1 or 2 devices connected, you build out your prototype, and then from there, you want to scale. So all of a sudden, 2 devices turn into 200, to 2,000, to 2 million, like literally overnight, particularly as consumers start to adopt your experience. There's a number of startups I'm working with in Australia in mentoring that have basically faced this challenge. Is they'll start off with a few devices for a client prototype, and then all of a sudden need 100,000 of them, and then have to manage them. So device management is totally something you need to keep in mind when you're building these experiences out. Ultimately, the device itself is only as smart as the library. And this comes back to once you get it to get a device connected to network, that's just the first part. There's a whole bunch of other things you need to do, things that we take for granted, particularly in the web dev world or in the mobile world. So with browsers, for example, there's a lot the operating system does to cache, the headers, the actual experience, the data being transmitted. It needs to render that into a page, etc. These devices don't know how to do it because, well, they've got nowhere to store it. They have to be able to process the information. And plus, like the tiny little things with no screen, they don't need all that information. They literally need a very light packet string to be able to send backwards and forwards. And so this is where what's known as an IoT broker comes into play. It's actually a protocol that was developed some time ago, and it was developed to be able to send information from a satellite to oil monitoring and oil sort of sensors, oil rig sensors and whatnot, for pipelines and stuff, called MQTT. It's a very light sort of packet protocol to be able to send small amounts of data, so temperature, light, etc., very, very quickly through the network. What's interesting with this, with some of the more mature networks now, is the header control and the header information in the actual packet send is able to be embedded into the actual network signal, so it doesn't get counted as data in the actual data send. And the actual protocol itself is very, very light. We'll have a look at it in a sec. I've got a bit of a demo to set up. How it works is on the right, we have our server. On the left, we have our actual devices, so a watch, a button, and a remote. Essentially, each one checks in with the server, and it's either going to have a device ID already assigned to it, or it gets one issued from the actual broker. From there, once they're actually registered on the IoT broker, each device can subscribe to one or many different topics. So it's kind of similar to a very simplistic messaging bus, where you can actually put messages into the broker, and then the devices, if they're connected, are able to pick that up. When the devices actually register online too, you can subscribe to a "Hey, I'm online" sort of topic, so that you know that those devices are connected. And you have a final sort of message they can send in to say, "Hey, I'm going offline." Although sometimes that's always not going to be a thing, because it's not going to have time to transmit it before it turns off. On the devices themselves, so usually there's a couple of different languages they're going to use. And again, these are really, really small, very, very low-powered devices. Like they're not going to run the full operating system that something like a Raspberry Pi would, because they don't need to. It's a very simple sort of loop that it's going to run. Mostly running in C, so Arduino C. The actual broker side of it is pretty much going to look like this. So aside from the broker and getting the information, you then need to know what to actually do with it. And of course, in the C world, you kind of have to tell it how to do everything. So once you get that message back to the actual device, you still need to be able to say, this is how you handle that. Providing it actually has sort of the programming to be able to know what to do with it. So in this case, changing a light to red, and then also putting that into the LED strip that's attached to the actual device through a particular pin. That's basically how it looks. So usually in Arduino, we have a setup, which is where you start doing your configuration beyond setting up some variables on the actual device itself. And then it literally just has a loop that is just going to keep running. The advantage to this, without not needing to have a full operating system, well, first off is power. And the second thing is, like, as soon as you turn it on, it's just going to do the thing. Well, ideally, you're going to hope it does the thing. You don't always know what it's doing. So I thought we'd do a quick demo on that. So I brought some props with me. So I was going to use, you're probably familiar with, I have so many gadgets in this amazing, do you all like the suit? So the reason why thank you. The reason why I wore it was I wanted to wear something with a little character. There we go. There's so many more. So yeah, I thought I'd use one of the little buttons, and I thought, no, we'll take that to a next level. So I printed. Let me connect this one up. Now, I'm also mindful that this is going to be a triple whammy demo, so bear with me. It's stuck. and it got stuck. There we go. So I printed a little bit of a bigger button. It's, yeah, fairly lengthy. And then also, as you can see, I've got a very big light bulb. So connect this up. Ta-da! So there's 60 addressable LEDs in that, and I printed this on an open source printer. So cool. The actual printer itself is rocking an Arduino, which I was able to upgrade with some community firmware, which was really, really cool. The thing that blew my mind about the printer was you can actually print a bigger printer with the printer. Inception. I actually printed some upgrades with it too, which was interesting. And again, there's a massive open source community behind that. Actually, before we left here, I printed so on the planes, there's when the tray table's up, I printed a bracket that I've now put on Thingiverse that allows you to put your mobile phone on the actual seat in front of you. So you don't have to hold it. You can watch your own shows right in front of you. If you want to check it out, just have a look for Developer Steve on Thingiverse, and it's the last thing I shared out. So let's do a bit of a demo with the broker. Okay, cool. Let me just make sure, yep, the right network. All right, so I'm using MQTT lens to connect to a broker. I've got a server running with NGINX on it, which is basically doing a proxy pass. We'll take a look in a sec what that looks like. Straight through to a server running Mosquito, which is an open source MQTT. Now, a lot of the different cloud providers have also their own version of brokers. There's no right one to use. The only right one is the one you want to support, in sort of my opinion. Mosquito is really cool. It kind of does the things you need it to do. It's open sourced. It's fairly solid. So the first thing I'm going to do on this is just subscribe to the topic that each one is going to be connecting to, which is lights. So now when these devices are already programmed to, they're already connected to the broker, I hope. Let me just check that. They're already connected to the actual broker. Yes, they are. And once I interact with them, so one's going to be listening, so the light bulb will be listening on lights as well for particular messages to go in. The button is doing both, so it's going to push a message into the broker, and then also it's listening as well because it's got a bunch of LEDs on the inside, so it'll be able to interact with that as well. First thing I'm going to do on here, and you can do the same thing from this client as well. So I'm going to push a message into the lights, and then I'll make them all go blue. So fingers crossed. I mean, what can go wrong? Triple whammy demo. Yeah. There's always that moment when it works. And so now what I can do, if I push this button, in theory, fingers crossed, it will also make it all go green. Oh, yes. Yes. I mean, yes, that was of course going to work. And then there's a few other things we can do with that as well, like programmed in to go red. So that should make it all go red. Yep. And then the final one is a bit of a feature with this one. If I hit rainbow, we should get a bit of rainbowness happening. Yeah, there we go. So the feature with this one, and this is kind of one of the things you need to be mindful of with the Arduino loop, is I basically get it to change multicolors for about 20 seconds. The problem is while it's doing it, it can't listen to anything else. Totally feature, not a bug. Can we switch back, please, to the deck? There we go. Okay, so on the NGINX side, basically I'm just passing through to an upstream, and you can have one or many servers as part of that to do some load balancing. Pretty easy. The ports you need to know for Mosquito MQTT is 1883 for unsecured, and then 8883 for secured. Of course, we only ever trust secured ones, right? Yes. There's some funky stuff you can do on top of that as well. So Liam Creeley did a really good post, and I'm going to reference it right at the end, just about using hash persistence as part of the upstream. Of course, using JS include, which, JS include is awesome. One of the cool things I've been doing recently was a thing called swarming the mosquitoes. So inside, of course, we all love Kubernetes. You can run a pod with Mosquito running on it. The problem is if you try and run multiple pods, they don't know what each other's doing. And if you push a topic or a message into one of the pods, the others don't know about it. Basically, what this repo does, and there's the link on there, and also this is on my GitHub as well, is you can put a JSON bridge in front of all three of them, or as many as you need, and they all know what each other's doing, which is so cool. And this is the sort of the important element of helping you scale to millions, billions of devices, is being able to sort of scale up the resources to accommodate accordingly. And of course, NGINX Plus and the Ingress controller sort of add to that a whole other level of balancing, which is totally going to cater for the billions and millions of devices that is coming and is here. Totally, and there's another pun there. Can you see it? And totally the thing to keep in mind is, like, with all this stuff, like anything I do as a dev, I always build for scale. Like, you're building for those billions and millions of devices, those millions and billions of users. Scale is always key for anything you do. So some further reading, which I thought might be interesting. So Beginner's Guide to MQTT, just for understanding how the protocol works and sort of some of the ins and outs of it. Amazing, really, really, really cool article. Liam Crilly's article, like, that one's gold. Love that one. And I just found this one interesting. There's some really, really good sort of tips and stuff in there. Just someone using Ingress controller in production, which I thought was really, really good as well. And finally, just to finish, I'm going to leave you with one of my favorite quotes that particularly relates to the IoT world today. The three most interesting things in the world are a programmer with a soldering iron, a hardware type with a program patch, and a user with an idea. In the IoT world today, that's everyone. Like, you do everything, even 3D printing. And that's kind of me. Thank you very much.
Awesome. Well, thank you, Steve.
Thank you.
Here, if I could just have you stand. So, great. So we've actually had a request from the audience. Evidently, you're wearing some snazzy socks.
Oh, I am. I have NGINX socks.
NGINX socks. See, I didn't even know. That was a grand reveal. First of all, that was illuminating.
Thank you. There's a pun there.
I can be punny.
I really light up the stage.
Oh, okay. All right, we're done. So I think we just have a few minutes. I think, one question I had is, I think you mentioned earlier that not everyone here is really involved in the IoT. It's just an emerging area. Mm-hmm. So for folks here, where does it get started? How do you get started? Do you do it at home? Is it something you see in companies? How do you advise people go and start taking this knowledge to application? Yeah,
really good question. So I guess the first place I first started using it was as part of the company. Like, it was back in the agency world days when we were having clients come to us going, we want to do real world activations. We want the button in the supermarket. We want the interactive experience. So I kind of just picked it up from there. But I guess with this stuff being so cheap now, like, there's nothing to stop you particularly automating things around the house. So being able to, those little ESP chips, there's a bunch of articles on putting them into light switches and stuff so you can activate them remotely. Stuff like that where you can interact. And because it's so low powered, and so cheap and low powered, you're not afraid to break it.
That's really cool. And then another thing is, I definitely saw NGINX in your stack, so that's awesome. How did you get started with NGINX? How did you get exposed to NGINX?
Again, back in agency days, so I'd come from digital agency world before being an evangelist. It matter of necessity. Like, it handled the load, it handled the experiences I needed to build out. Like, it handled the scale really, really well. Back in 2013, I've been using it a while.
Excellent. Well, cool. I really appreciate you taking the time to come here all the way from Australia.
Thank you.
I think the audience will definitely have time. I think you're around for the rest of the day. So if anyone wants to find Steve, you can message him in the app, or you can come find him. I think there's lots of really good.
Thought we could do a quick selfie.
You want to do a quick selfie?
I do. So I got a new 360 camera just for this trip.
Oh.
And the best part is you don't have to try and line it up the stage anymore. Like, I can get you all in it at the same time.
All right, let's do this.
Do a quick selfie. Everyone's got a smile, though.
Yeah. This is tripping me out. So we're on camera and they're on camera.
At the same time.
This is going to change stages. Selfies.
All right, ready? All right, 1, 2. Everyone's got to say cheese. 1, 2, 3.
Cheese.
I'm going to take a couple just to make sure.
Redundancy.
I can't do do-overs. All right, cool. Thank you very much. Thank you.
Are you going to put those on social?
I will.
All right. Thank you, Steve. That was awesome.
Thank you very much.
Really appreciate it.
Thank you.